I'm rolling, okay?
All right. I thought you were.
So Gloria, you have a question for me? Just tell everybody what it is.
My question was, what would happen if like a giant metal ball surrounded the Earth?
Metal ball?
Like a sphere, like that.
Like a hollow sphere?
Yeah, kind of like the atmosphere, but lower.
Lower?
And metal.
A metallic sphere surrounded the Earth. So you're asking what happens if there's a metallic sphere surrounding the Earth? Like encasing the Earth, the whole entire Earth? And then it's somewhat of of a height from the Earth?
Yep.
That's not gonna collapse all the mountains and all that?
Like, I would say 70 feet above the highest point of the Earth.
So 70 feet above Mount Everest.
Yeah.
So that's a good question. It got me thinking, right? So, theoretically, you could balance out, right? Because the gravity is pulling the sphere down toward Earth, but it's pulling on all ends, all sides, right? So can it be balanced out? What do you think?
I ask you.
Basically that's your question. If it's balanced. So it's somewhat tricky. It reminds me of that movie, Spaceballs, right? And then there's Planet Drooling Idiots. Is it? Idiots?
They've reached the air shield.
And it's opening!
The ship's too big, they'll never get through.
Maybe
Okay.
it's.
So yes, that planet, they had a similar thing, right? It's only that it's transparent and lets the sunlight in. Nice one, Ethan. So it lets the sunlight in and but locks in the atmosphere, and then it's sort of like a whole protective sphere outside of the atmosphere, right? So something similar to that.
Don't close it.
So when we think about it, the Earth and whatchamacallit, the sphere itself, they're both three-dimensional, right? How we think about problems is that we like to reduce it. Think of make a simpler problem, and then see if we can get some insights toward it, right?
It's like algebra.
It's like algebra.
Let me have the charger. It's my charger! Have my charger! Okay.
Can we trade skins? I'll trade you this for that. What?
So if we have a three-dimensional problem, we can reduce it into a two-dimensional problem.
Does one-dimensional exist?
Yes, one-dimensional is a little bit weird, and it's not connected anymore. It's hard to have it like a connected. So basically you have one thing that has 2 points suspended to it. But in a two-dimensional thing, you can have something surrounded, right? Okay, so what do you think? So if it's a two-dimensional problem, right, we could have one point in the middle, right, and then it has a gravitational pull on the ring on the outside. Does that make sense? So I'm thinking that we could actually test out our theory to see if it actually would work, right? So if we have a magnet in the center and it's sort of a ring on the outside, maybe a keychain ring sort of thing, then we can test our theory. My guess is that it's going to collapse at one point. Okay?
But
so
then
let's do that.
there might be like a point where you could just perfectly place it for it to be in the center of the
Yes. If it's precisely at the center,
But it's really
and then
hard.
the pulling on all sides are going to
They pull
be
into
the
each
same,
other.
right? But if it's off-centered, just even the slightest little bit, then it's going to collapse onto one one side, 1 point. So that's my guess. Okay, let's do the testing.
That's my hypothesis too.
Good, good.
You are watching the spherical cow.
We're assuming this is our Earth. This is a magnet.
What's that?
One of these?
What's
That's
that?
just a grape.
Oh, then I'll eat it.
Okay, this is our sphere, two-dimensional sphere. We're gonna place it around the Earth. And
Can I place it?
Try not to. Okay, you can try it. See if you can do it.
Whoa, it's already moving.
Use the other hand.
Oh.
So always look at it.
What if the table's curved?
It's gonna be attracted to some point, right? Okay.
Let's
So we
try.
can't even put it in place, I guess. So even if it's in place, as long as you tug it a little bit, it's gonna roll over and stick onto something.
There has to be a perfect. This is
Alright, let's try.
representing our aluminum or metal ring.
Yes. Okay, your hand is blocking it.
Ah. Okay, let me show the camera.
Yes.
Okay. So no matter how hard you try, I mean it's possible, but really hard. There's so many factors.
Practically, it's impractical. Let's put it that way.
Ugh. See, when you try to pull it off, it goes to another side. I think it's part of the reason because the magnet's very strong. I don't think gravity would be like that. Because I was saying like it's above the earth in like an even place, right? Let's try this bigger.
Yeah, move it in the frame.
Okay,
Too close.
can't see the frame. Okay. Ah, see, it's almost impossible to peel it off or place it perfectly. I have hiccups.
Okay, I think, have we had enough?
Yeah, I don't want to do this anymore. Goodbye, darn magnet.
I don't want to do this anymore. Oh,
I
this
have
is
a bigger
Earth.
magnet.
That's like a Jupiter, huh?
It's a Jupiter. Jupiter's not
Move it
gonna.
over.
The ring's not gonna stand a chance against Jupiter.
Yeah, Jupiter's too strong. Ah, Jupiter.
Nobody can stand a chance against Jupiter. Jupiter is.
Maybe put a ring down and put Jupiter in. Yes.
What?
Okay. All right.
Okay.
I think that shows our point that it's not gonna work. Basically,
Yeah.
Right?
It's
unstable.
highly impossible.
It's unstable.
At least human hands can't do it. Maybe if a machine can, maybe it's possible. This is very frustrating. Okay, bye. Back to the question. So the conclusion that we came to is that yes, the metal sphere can stay in place on top of the Earth, but as long as the Earth is very stable in the very center and every gravitational pull for the metal ring is even. So the experiment that we did not turn out too well because, well, it did tell us what we needed to know, but then what it showed us is that the magnet, it depends on how balanced and stable the magnet is and where it stands, so then it can stay in place. If there's the slightest movement because of the Earth's gravitational pull, then it's gonna stick to one side. And also, we can reverse that if we had on the other side, if we had like a vacuum ceiling or like a air pressure?
Well, we couldn't show that because magnets are not exactly like gravity.
It's very attracted to the ring. So,
Yeah, so that's the concept right here is stability, right? Something is stable. Something can be balanced doesn't mean it's stable, right? It's like put a plate on top of a stick or something, right? Try to balance a plate on top of a stick. That's really hard because even though if you can do it,
you can probably do it if there's a perfect kind
you can find a perfect balance of it, but it's very fragile.
centric
right?
mass.
So a system like that, we call it unstable, right? Okay, so we learned something today, have we? Oh, very good. Stability is a good concept. Okay.
Peace.
Say bye, Ethan.
This is the spherical cow. By the way, my dad's the spherical cow.
This is a series dedicated to teaching everyone a little science through teaching my kids born in 2007 and 2010. Spherical cow is a common but lame joke among the physicists. They tend to oversimplify problems to gain insights, but it works.